Hello, welcome everybody. Welcome to the Routing Loop, our weekly show on all things networking. We're at the end of the security season. So the last few weeks we had a bunch of security sessions. So this is our final and, dare I say, best security session left for the end. We have great guests today that are going to talk about AWS Network Firewall and some of the launches we had with it in the last, I guess, a year. I'll let them introduce themselves. Maybe Sophia, you want to go first? Give us a little bit of an intro, what you do, where you're based. How long have you been in AWS?
Sure, happy to. Hey, folks, my name is Sofia Aluma Santos. I lead our network and application protection go-to-market strategy worldwide in our security organization. Spend lots of time talking to customers about all great things like network firewall, network security. Um, I am based, it's a fluid concept, honestly. I'm based in Seattle now, but recently moved from the Bay Area. And then a year before that really was in Austin. So it depends on the day that you ask.
Are you?
And I've been at, oh, what was that?
No, I was curious if you're like going, you want to get worse and worse, progressively worse weather. You started with Austin, then you went to the Bay Area, and now
Hey, that's
Seattle.
subjective. That's totally subjective. I've been at AWS going on, man, 3.5 years now. Getting close to 4 years now. Really enjoyed the time, been in the security group the entire time and really loving it so far.
Very cool. All right, Jesse, what about yourself?
Hi, everyone. I'm Jesse Lepich. I'm a security SA with AWS, and I focus on perimeter protection services. And I work with a lot of our largest customers to help around best practices and making their implementations as smooth as possible. Let's see, I've been here for almost 6.5 years. Yeah, it's gone by fast.
Wow. And I know me and you have done a show before, and we got a little snippet from it. This
Yeah,
is, was that 2023, Jesse, you were saying?
so I think it was 2023. Yeah, that was the my COVID beard was still on. So I'm surprised you're inviting me back. Thank you. Thanks for having me
I
back.
was gonna
No.
say, was that No Shave November?
Yeah.
My 9-year-old son the other day, he's like, Dad, I actually really miss the beard. You got to bring the beard back. So who knows? Might come back.
Yeah. How long did it take you to grow this thing?
Oh, I want to say that was about a year or so. That was some dedication. Yeah.
Yeah, commitment. I can't do
My
it. As
my
soon as
lumberjack era.
yeah, it gets itchy and then it's yeah, I have to shave some of it at least. Yeah, but the look suits you for sure.
Thanks.
Cool. All right. So Sophia, I believe you're going to lead us in with some background about Network Firewall, but we'll have a mix for everybody today of a little bit of slides. I think, Jesse, you have some walkthroughs in the console. We'll have a little bit of a demo. And if folks, as always, have questions, pop them in the chat and we'll answer them as they come through. All right,
Awesome.
Sophia, going to pop your slides up here.
Yeah, and again, thanks for having us on. As you mentioned, we've had a very exciting and kind of robust year for Network Firewall. There's a lot to share, especially reinforce season. We had a series of kind of big launches, so we wanted to get a chance and walk through what they are, what it helps customers do, and maybe some of the kind of new best practices around those. But real quick, just to level set, AWS Network Firewall is essentially the cloud native next gen firewall inside of AWS. And what folks really love about this service is they love the ease of use, kind of highly availability, customizable, robust, managed aspects of this solution. And it's essentially a way to deploy network protections for your VPCs. It's based on a Suricata engine, so the rules are highly customizable, but you can also perform deep packet inspection, domain filtering, IDS, IPS, and more. We have these managed rule groups that kind of simplify some of that policy and rule management. Um, and something that's worth noting, you know, like kind of pay-as-you-go cloud managed services. These are kind of no upfront commitments. Customers love that aspect. But the NAT costs for AWS Network Firewall are waived. That's something that we're working on our kind of pricing calculator to make sure that it is discoverable and easy to see. But that's something that a lot of folks often miss when they're kind of comparing their options.
Yeah, I've seen that as well before, where a lot of customers didn't realize that not gateway costs were included if you were also getting a kind of a full deployment of a network firewall.
Exactly. And I touched on these, but folks love the AWS Network Firewall solution for these kind of highly scalable options, the ease of use. It also integrates with some of our partner solutions, but also, within our own native solutions and more as we work to, and we'll touch on this today on some of these new launches, we'll start to see more and more of these kind of integration and attachment points that kind of abstract manual aspects of having to set some of this stuff up and getting that benefit, and really just kind of manages and just makes it easier to use all across the board. And then how we want to just think about some of the new launches and features that we're talking about today is really in the perspective of some of the pain points that we hear when we're talking to customers at scale. And these are broad kind of network challenges, but also unique to some of the kind of cloud and on AWS type of challenges. So, obviously compliance is a big piece. That's why folks gravitate to AWS network firewalls to, kind of work towards those, meeting those compliance regulations, but also needing additional visibility. Folks tell us that they need insight into their traffic patterns, kind of who are their top talkers, uh, needing to stay on top of ever evolving kind of threat landscapes, and more and more anything that can help them demystify, simplify, take away the complexity that requires and burdens, kind of their security teams. So with those challenges in mind, these are kind of some of the pillars that we worked backwards from, and we'll touch on. And I want folks to keep those kind of these three in mind when we talk through some of the launches that that we worked backwards from. So when we talk through complexity, visibility, threat landscapes. These are some of the things that guided our priorities to these launches in these last kind of 12 months and going forward. So ease of use, and Jesse will walk us through some of these, where we're working more and more to help folks understand how to set up their allow lists, their policies based on their own existing traffic. So we'll walk through things like the automated domain list builder feature that essentially analyzes your existing traffic and recommends domains to block or allow. Some more flow management capabilities, native attachments to some of our adjacent network services, and then we'll walk through a really cool active threat defense capability that we are now exposing through AWS Network Firewall through a managed rule group. And then we'll also walk through our dashboard and some of our other capabilities that offer some optimization, like multiple VPC endpoint support.
And it
Uh,
sounds like, Sophia, we want to hear feedback from everybody, right? If customers have other use cases, challenges, we're very open to hearing what those are, because it sounds like a lot of the features that we launched were based on the feedback we've already had from our customers, right?
For sure. That's something that I really love about AWS and this team is we're always hungry for feedback. That's when I think everybody perks up. So let us know, if there's something that you don't see, or if maybe there's a use case that we didn't think about that we can open up through something that, we can do fast follow. We'd love to hear that as well.
Yeah. even if you ping us on LinkedIn, I actually have a few folks that I have like open threads on LinkedIn, and they have some very interesting use cases, feedback on how they use our services. And there's a lot of good nuggets in there that we can pass on to the service team, even if it's just like a LinkedIn message without kind of an official feature request.
Absolutely. And then one last kind of uh, food for thought. Jesse and I always love this quote, but egress and egress controls is one of our biggest use cases that we see customers use network firewall for. And if you talk to a red teamer like the CISA red team, uh, they'll say, if you want to make my job difficult, deploy strong and robust kind of outbound controls and egress controls. And what's more, consider working towards an allow list of domains. And kind of with that in mind, that'll tease into some of the launches that we launched to simplify those use cases.
Yeah, but I remember seeing your talk from Reinforce. I think you were touching on similar topics, and it sounded like allow lists are pretty tough, right? It sounded like it's easier to start with a deny list, and like because trying to get an allow list correctly out of the gate is probably a tough nut to crack. I don't know if Sophia, Jesse, you have comments on that.
Yeah, definitely. So we always recommend that customers start with deny list, and AWS Network Firewall has managed rules that help customers very quickly block, for example, high risk known malware download, command and control destinations. So it's really quick and easy for customers to start there. But then we also have a lot of customers that want to build on top of that, continue to reduce the risk surface by applying an allow list. And so some of the features we'll talk about today are around how do we make that easier. We know it can be challenging, especially if you try to do a really strict allow list. So we'll walk through some of the features that help there. And then some of the philosophical things that we've worked through with large customers and their deployments is around the approach. Where should you start? Where should you kind of incrementally improve and maybe be a little bit more strict down the road? So we've tried to develop quite a bit of content on that. And to sum it up, we usually recommend that if customers are interested in an allow list, start with what we kind of call a generous allow list. Maybe that's a little bit wider at first, and then you can start to iterate on that, and you can narrow it down if you need to. But even an allow list that might on the surface seem really wide, it's much more secure than just default, everything is kind of available and accessible. So getting customers through this journey is really important for us and making that easier.
Got it. So it sounds like allow list is the peak at the end of your kind of maturity, but you're starting with this, the low hanging fruit is a deny list, and then you can kind of progress to an allow list.
Yeah. And in particular, a strict allow list. So there are ways to do, if you think of like regex, you can do regex with network firewall against domains. And so you don't have to have just a very strict allow list at first. You could say, for example, we kind of trust these partners and they all have partner XYZ in the name. And we don't have to have individual domains learned and applied in our firewall policy to write that sort of rule. We can if you want, and we have tooling that can help with that. But usually customers want to start with something a little bit broader, easier to manage. That way, as their applications change over time, the firewall rules don't have to be fiddled with and adjusted all the time.
Yeah. I see there's a question here from the chat that might be interesting, uh, about identifying places that there's no traffic to. So then you kind of can prune the destinations that you're not going to. I guess we're going to look at some options of how you can even get started with it so that you maybe
Yeah.
don't need to prune, but you start off with a list of things that you do need to go to.
Yeah. Yeah. So in general, we recommend customers start with the built-in deny list. These are managed rules. And then also think about your own custom deny list. For example, it's very popular to see customers configuring rules that would prevent traffic going to certain geographic areas. So with network firewall, you could say, hey, these geographic areas are off limits. My workloads have no business talking to them. You can always start out in alert mode, so you don't have to, you know, um, make that block decision at first. And then you can take the same idea with domains, top level domains. There's great research around which top level domains are highest risk. One of the huge advantages we see for AWS customers is they usually have fairly predictable workload behavior. It's usually a VPC, machine workload in a VPC, and it's easier to identify what the legitimate scope of that behavior needs to be and start working towards that allow list, which means there's a lot of room for being able to just block things that they have no business talking to. And you can very quickly identify, hey, these haven't talked out to these top level domains in the last 6 weeks, so let's just put a block rule in place for them.
Okay, cool. I think it's going to become a little bit more clear as well, some of those when we start looking at examples, Jesse, that you have for us.
Yeah, and I get wound up on this topic because it's exciting to see customers actually preventing bad things from happening in their VPC. We're really big on, are there things we can do that materially impact the security, and don't just fire an alert for someone to follow up on. Sure, we can fire alerts for people to follow up on as well, but let's look for those areas where we can proactively block the bad thing.
Got it.
All right, so are we jumping into the console?
Let's do it. Yeah.
I think. All right,
Perfect.
Jesse, you ready to go?
I am ready to go. Yeah.
Let me add your
Wanna,
share here. Okay, let me just gotta remove the old one, and then I can add you here.
Perfect. Thank you. So first and foremost, I want to start with the best practice guide for network firewall. This is based on a large number of production real world deployments of AWS Network Firewall. And so it's our learnings. And so Sophia had mentioned Network Firewall has a rule engine called open source Suricata that's very flexible. It also can be complex if you want it to be. And so what we've tried to do here is simplify it down to the specific things that the vast majority of customers are going to benefit from. And so we have things like a full egress template that you could copy and paste out of this best practices guide into your firewall, so that even if you don't know how to write any Suricata rules, you can easily take advantage of that policy. And then you can pick and choose and decide, well, hey, maybe there's certain things, certain use cases in this policy that I don't need, or you can adjust them, you can comment them out. So this is an excellent place to start your network firewall journey for sure. And we update this all the time. So like I just pushed some updates to this the other day based on some new features in network firewall and that sort of thing. But I want to jump over to the actual console for network firewall and walk through some of the recent features that we've launched. So this is my network firewall, my list of network firewalls in my console. I'm going to drill into one of them here, and we'll walk through some of the new features. So one of the things customers have asked for is increased visibility and understanding of what is my firewall actually seeing, and how can I draw insights out of its deep packet inspection engine really quickly. So we've added a monitoring and observability dashboard here. Up until a few months ago, this was pretty basic, how many packets in, packets out, and that information is still there, of course. But if you scroll down, you can see that we've added more details around um, around insights from the deep packet inspection engine, like top domains, top TLS traffic, top destinations, top dropped connections. So it's going to give you a lot more insight into what this firewall is seeing without you having to know much about, do I use Athena to query my alert logs? Do I use CloudWatch log insights? All of these things are kind of just pre-canned and very useful. So I
Do I
can
need
see
to? Yeah, sorry, Jesse. Do I need to enable logging explicitly for this to work?
Yeah, so the way it works is you turn on the logging in the firewall, you choose a CloudWatch log group for it to go to, and then the dashboard sees that and starts to populate these widgets and dashboards proactively for you. So a lot of this you could do on your own dashboard in CloudWatch logs, but this just kind of short circuits that process where the things that you're likely to want to have, they're just built in the console here.
Got it.
Yeah, so Network Firewall produces what are called alert logs and flow logs. The flow logs are interesting because they're a lot like VPC flow logs. they see only from the perspective of the firewall, though. So if I don't want to have to turn on VPC flow logs in all my VPCs, but I still want to see what's traversing the firewall, it will emit those logs. And those can be useful for collecting the amount of data. This information is not in the other log in network firewall, which is the alert logs. So you can get kind of both sides of it. So I see top talkers. I can immediately see who's consuming the most bandwidth across this firewall. And any of these items I can obviously key off of and go straight into log insights and search for more detail if I want to view the actual raw JSON log. I can see top rejected traffic, top drop traffic. Rejected is an action in network firewall. Drop is another action. Both of those are things that block traffic. Rejected just means it's going to send a TCP reset when it blocks that traffic. And then I can see things like tops TCP flows that don't have a two-way communication going on. So this could be something like maybe I have a networking issue with asymmetric routing, maybe a routing loop. Maybe I have port scanning or some sort of reason why there's traffic kind of only going in one direction and that return traffic isn't seen here. So it gives me quick insight into what happens there. Actually, Tom, are routing loops even possible in AWS? Don't we like
No, no,
those? Yeah,
you
yeah.
can't. Well, I guess you could create your own routing loop where you would
After an
have
overlay or
routes around, but then there's a TTL on each packet that would eventually expire. So in theory, you could create a routing loop, but you can't create like a broadcast storm
yeah,
or a spanning tree loop because that's not relevant to the
yeah.
cloud. So
So I made
that's.
a technically inaccurate joke there. I apologize.
But now I think we should have everyone involved in the show actually try and weave in routing loop
Yes.
somewhere legitimately.
Awesome. Okay, so top live, long live flows. These are flows that indicate, there's active communications between applications going on in my environment across the firewall. Top HTTP host headers, top URIs. So a lot of folks don't know that network firewall can see deep into even the file name and the URI for HTTP traffic by default. If it's TLS traffic, obviously that's inside of the TLS. Network firewall does have TLS decryption capability. So if you wanted to drill into that information, even for encrypted traffic, we can. It is an additional configuration that has additional costs associated with it as a premium feature. And then top TLS SNIs, these are the HTTPS domains. This is really getting to one of the most popular use cases for a network firewall is domain filtering. Customers want to be able to control, they want to be able to block known malicious domains, of course, but then they want to be able to get insight into what's being accessed without having to decipher from IP addresses, what is on the other end of this IP address. And so we can pull this information from the network firewall logs very easily. And then this is a feature, excuse me, we're really excited about. Since we kind of watched and helped a large number of AWS customers work through their egress deployment, we noticed that a lot of them are working towards an allow list, which we love. We kind of have steps for making that easier. But we thought, why don't we just make a feature in network firewall where you would have like a learning mode and you would be able to turn the firewall into alert only mode, learn what's happening, and then easily convert that into a firewall rule set. And so that's what this feature is for. This is automated domain list feature. And when you turn it on in analysis mode. It will collect data for a 30-day period of time. And then it'll allow you to generate these reports. And so I can jump into the report. I've obviously already collected the data here, but then the report will show me what are the top domains being accessed by my environment. It shows me the number of access attempts, and unique sources is also here. We thought this was important to include so that not only you can see access, which domains are accessed often, but you can see how many workloads in your environment, how popular it is with your workloads. And this can help you determine like, okay, maybe there's a misconfiguration. This workload shouldn't be reaching out to a domain. Maybe this will help bring insights into how you could add new domains to your allow list. But the whole idea here is bring insights very quickly, show you when it was last accessed, when it was first accessed, and then you can create a domain list rule group based on those insights. And a domain list rule group is just a firewall policy. It's an allow list that says the domains that you saw here, um, quickly convert those into a rule group that only allows those domains. So now it populated these in, and I can very quickly associate this with my firewall policy if I want to move towards an allow list. This is our very first step in this kind of idea of a learning mode and allow list builder for network firewall. I think there's a whole bunch of cool stuff we can do on top of this foundation. And you'll see future features for network firewall being woven into this allow list builder as well.
Hey, Jesse, how would people keep this up to date? So,
Yeah,
say I've set this list up after 30 days of getting populated by the traffic I actually see, but maybe, Tom wasn't there for a month and he accesses
yeah,
a lot of weird stuff, and now we need to allow it. Uh,
yeah.
would you go back to the report and just re-implement it? I
So
guess you also probably don't want to lose anything that you already allowed.
yeah. Yeah, so I mentioned that it's our very first step. It's foundational to have this allow list learning mode, but it doesn't have everything that we would love for it to have. One of the things we're thinking through is how can we help customers adapt their allow list over time, maybe automatically. So maybe again, this is just theoretical. We're just talking through some of the requests that we've had from customers. Maybe you set a policy that says whenever you see that all my workloads are accessing this new domain, send me an alert and allow me to automatically add it to the list, that sort of thing.
Yeah, that would be nice.
Those are
But
just ideas. You could certainly today you could build custom automation to do that. We've considered doing that and then publishing that in the GitHub repository. We just haven't done it yet. What we would really love to see is those sort of features be baked in as native features eventually.
yeah, and I see a question here from Keep Learning about, being able to deny based on categories. I understand today it's mostly the list that you manage, where categories are not yet supported.
That's right. So today the categories are bad categories like malware, command and control, threats, well-known high-risk threats. Um, Roadmap items I think are off limits for this discussion, but there are things that we definitely get requests from customers around supporting other categories in the future.
Got it. Yeah, I've heard it many times before. It's a common ask as well, right? Yeah.
Cool. Okay, so that's ADL where we learn the domains, allow you to quickly convert those into a managed rule group if you want, uh, into a customer managed rule group. But I mentioned we also have AWS managed rule groups. And so in the past, we've had these, well, my screen's kind of weird. I'll do a lot of scrolling here. In the past, we've had domain and IP rule groups. These are managed by us. You don't have to keep them up to date, right? And then we also have threat signatures. These are IDS IPS signatures. And again, we keep them up to date. You can see when they were last updated. You can quickly add them to your policy. Those are a great place to start. And what we recently launched is our ATD, our Active Threat Defense Rule Group. And so what this is, I'm going to jump into this rule group. It's another AWS managed rule group, but it has threat intelligence specific from AWS environments. And so you might be familiar with guard duty. Guard duty can alert on things that we know from our wide perspective across all AWS environments. This can alert on those things and proactively block those things. And primarily that information, this threat intelligence, comes from our honeypot network across the globe. So we have tens of thousands of sensors across the globe in AWS regions that are watching. They mimic production applications. On the internet, they look like they're adjacent to production applications on a public IP address. They mimic things like WordPress and SSH and on and on. And then what they really are meant to do is try to learn what are the follow-up actions that attackers are trying to do. And so, for example, if an attacker SSH'd into one of these things, maybe they brute force their way in, right? We want to see what are they going to do next. In a lot of cases, they're going to try to download some sort of payload so that they can control the workload, a command and control agent, or they're going to, make direct to IP communications calls over a certain weird port, asking for a certain malicious file name. We collect all that information from our honeypot network, and then we populate these rule groups with that information so that network firewall customers can quickly block these threats, even if their AWS environment wasn't at all probed for these sorts of things. So it is very proactive and very specific to the intelligence that we see related to AWS VPCs.
Yeah, this is
You
a
can
really cool one because if you think about just the scale of visibility that we have from a potential attack surface perspective, just from our AWS global infrastructure, we have like what MadPot allows us to have is essentially decoys across our entire infrastructure and thousands of sensors deployed there, and I think something like it's 100 million daily attempts that our sensors pick up, learn from, analyze, and as we have these essentially vulnerable services that we emulate, we learn from that behavior, and then this rolls into our existing infrastructure, but more and more with this threat research team and this active threat defense. We're rolling it into essentially giving customers the ability to take that and protect their own environment.
Yeah, I was thinking recently about that. It's probably also super critical to have your honeypot in the right place, right? Because I was thinking if I would deploy a honeypot and put it behind a random IP address and without any useful domain, it's probably going to get some traffic, but it's going to get like tiny amounts. But if we can hang off something that's popular and have like a path that's pointing to a honeypot, immediately you're getting like the actual proper data, not just just a random endpoint somewhere on the internet seeing
Yeah.
whatever's out there.
And then emulating things that are looked to be vulnerable, or maybe things that just popped up. And there's a lot of options for us to be able to collect unique insights and then push that data into network firewall customers rules proactively. I always get the question, well, how often are these updated? We don't publish like an exact interval, but if you watch the last updated, you can see they are updated quite a large number of times throughout the day. Um, Again, no commitment on how often things are churning, but the idea here is we know there's a big challenge with threat intelligence that it can retire out and become stale and old. And so we want to help customers make sure that the active threats that are important to their environment and there's active probes against those sorts of things, that those are blocked, and we're automatically retiring out things that maybe have died off and don't need to be blocked. So we take care of all of that for you. There's an additional feature that we're adding to this. It's sort of like in preview, you could think of today, where we have deep. You can opt into um, what are we calling it? Deep threat inspection, which essentially looks at what traffic is triggering these in your specific environment. It allows you to share that information back to us so that we could see in the future things like, hey, you know, uh, 500 different customers are being actively hit by this thing. Maybe we reach out to them. Maybe we, adjust our rules accordingly. So there will be a kind of a feedback loop there that's in addition and beyond just our honeypot sensors. You can think of it as almost turning every firewall that opts into this feature into a honeypot in a way, because now we can get its perspective based on those threats. You can look at the threats and see some. You're not going to see exactly how the rule is written. Obviously, we don't want to reveal that to attackers, but you can see what they're related to. Things like URLs, staging, malware, command and control, HTTP host header, HTTP file name, TLS, SNI, JA3, JA4, all those sorts of things are things that we can collect and take action against in Network Firewall. Okay, I've hit on that for quite a bit. We're super excited about that. It is a very unique, differentiating capability. I mentioned that Network Firewall is one of the most popular use cases is for outbound to egress control, domain filtering, but it can also be used for ingress filtering. So if you, for example, had an NLB that doesn't support WAF, but maybe you want some protections on that, network firewall can sit between the internet and that NLB and allow you to add this sort of threat intelligence and automatic protection to that NLB. So this is related to attacks that are both ingress, things coming in from the internet into your environment, as well as attacks related to things that an attacker might be triggering your workloads to reach back out to the internet, command and control, malware download. So both of those use cases are covered by active threat defense. Okay, so a couple other features in Network Firewall that we've recently launched. If I go into my firewall again, we have a flow capture and a flow flush feature that's relatively new in the firewall. What this allows you to do is you can, in the UI, you can see active flows going across the firewall. You configure a flow capture. What that means is you basically tell it what AZ you want it to run in, what the source IP address is, what the protocol, what the destination IP, or you could just do any. And it'll start to monitor those flows and give you insight into what flows are actively going over the firewall. And then you can use that information to flush the firewall flow state. That's a mouthful. And so why would a customer want to do this? Where there can be situations where you might have like a really long-lived flow that you want to interrupt. Maybe there is, hopefully this doesn't happen to you, maybe there's a workload that's actively communicating with something that it shouldn't communicate with on the outside, and you want to kill that connection. This allows you to be able to write rules that actively block and impact that connection. It also is really handy for troubleshooting rules. As you add new rules, let's say you're developing your firewall policy and you want to see what is the perspective of this brand new rule set immediately, even against flows that are actively going over the firewall, you can choose to flush the firewall flow state and it will relearn everything, relog everything against the active firewall policy. So this is a new feature. There's also another way to flush the firewall flow state called stream exception. So this is an option and it allows you to, you can do it on individual flow level. But if you just want to flush all the flows, you can go into the stream exception setting of the firewall. I'm getting really in the weeds now. You can change this from stream exception, whatever it is, to something else and then back again. And that also is a way that kind of tells the firewall, relearn everything, even existing flows against the current firewall policy. So if you look at the best practices guide, we mentioned all these sorts of little tips and tricks and things to make it easier for customers to troubleshoot their firewall.
Got it. So that's changing that stream exception policy will ultimately drop all of the flows that the firewall is tracking, and then uh, whatever is the whatever you configure the policy to, I guess, in the new version, then existing flows will apply to this new policy. You want to spend a little bit of time, Jesse, explaining what is the stream exception policy? Because I think it used to be quite relevant.
No, I don't. Let's not. This always makes my head hurt thinking through. No, no, it's you're absolutely right. It's way less relevant than it used to be because we have a new feature in Network Firewall that does state sharing. So Network Firewall consists of a fleet of EC2 instances that are doing the actual inspection. And Gateway Load Balancer is a foundational element of Network Firewall. It's built in, no additional charge. And Gateway Load Balancer's job is to make sure that flows are load balanced across an individual inspection instance in both directions so that the stateful firewall can see both directions and take action on that. It used to be that there might be cases where there could be a maintenance event where a flow would accidentally end up on an instance that it didn't have any context for because it just landed there and it's like, I didn't see the initial setup. I don't know what's going on here. And so that's a stream exception. And so this setting, how do we handle that? Do we want to drop the traffic, reject the traffic, which means block it and send a TCP reset? Or do we want to just continue and allow the traffic if this sort of event happens? These options are still here and available, but they're way less applicable now that we have state sharing. So the instances in which you would have stream exceptions, where a flow just lands on an inspection instance and it doesn't have the context, is very, very minimal. Most of the time, the instance is already going to be pre-populated with the full state table before flows start to land on it. I hope that clears it
Yeah.
up.
So that sounds like a nice benefit of the managed service, right? Because there's a gateway load balancer, there's a bunch of EC2 instances that are actually doing the inspection. None of this you have to worry about when you're deploying a network firewall because it's all managed. But it's good to know that we are now exchanging the state table between all of the instances that participate in inspection of your firewall. So then if one of them fails, it really doesn't matter. Gateway load balancer is just going to move that flow to another EC2 instance, and that already has the state table in there, and it will kind of understand what to do with this flow. You don't need to do any additional configuration of what will happen if an instance doesn't know about the flow. But I guess in scenarios where you're like doing major resets and those new flows are flooding in, maybe that's when those exception policies could make sense.
Yeah. There are asymmetric routing scenarios that sometimes trigger an asymmetric or a stream exception. And so this it does emit a CloudWatch metric. So you can see how often this is happening in your CloudWatch metrics. It's very infrequent these days that this happens. But if you have consistently stream exceptions, it usually is an indication that something weird's going on the networking side. Maybe a route was missed, return route needs to be put in place, that sort of thing. So we do mention those in our best practices guide. Cool. Okay, a couple other features newer to Network Firewall. You can see over in the left here in my Network Firewall console, there is a VPC endpoint associations. I won't dig into like all the nitty gritty settings in here, but essentially what it allows you to do is take a single network firewall and you can deploy primary endpoints into another VPC so that you can protect that VPC. And then you can deploy secondary endpoints off of that into other VPCs. And what this ultimately means is you get a distributed network firewall model where you can, if you choose, you can deploy directly into application or developer VPCs with a single network firewall, and you don't have to pay the primary endpoint charges for all those different endpoints. There's a secondary endpoint that has lower usage charges associated with it. So it's a more cost-effective way to deploy in a decentralized model, meaning we're pushing the firewall protection down to the VPCs.
I think we have a slide for it, so it might be easier to also, Sophia, you had a,
Perfect. Thank you.
yeah,
Yeah. If you want to walk through there, we have a before and after.
because
Yeah,
those
this is
those
excellent.
architecture plumbing situations, I think those require slides. I think the features where like configuring policies, those work really well in the console, but as soon as
Yeah.
it's like
Yeah.
connectivity, you gotta have a drawing.
Yeah, so what we're showing here is the network firewall service VPC on the far right. That's that fleet of inspection instances, that's gateway load balancer. That's all stuff AWS manages on behalf of customers. A customer would decide where they want to deploy the endpoint. That's in the availability zone A, VPC A, and account A. And so the model today is that they would choose which AZs, which VPCs, where they deploy that, and then AWS manages all the things on the right. Before this feature, you had to deploy that primary endpoint, which does have an hourly cost to it and charge, into the VPC. And if you wanted to do that into a lot of VPCs, those hourly charges would rack up and end up being pretty substantial. Now, with this new multi endpoint feature, which is the next slide here, we allow customers to deploy the primary endpoint and then multiple secondary endpoints so that they can push out this firewall protection to a lot of VPCs without having the uh, primary endpoint charges for every one of those endpoints. So this is what we call our distributed model, where we have a single firewall that's being pushed out protection to other VPCs. And the multi-endpoint feature makes that more affordable. However, It's a great feature. We're glad it's there. Its use cases make sense in some situations. We still see customers preferring a centralized deployment. Hopefully, we have a slide on this. But most customers, especially if they have a lot of VPCs, they will tend to prefer transit gateway with an inspection VPC, and they'll actually take the traffic from their VPCs that they want to protect. They'll route that through TGW into an inspection VPC where network firewall lives, and then onto its destination. That is a very popular deployment. It allows customers to simplify their network architecture and still have a single place where they manage everything. And in that architecture, they're also able to reuse, if you will, a few number of firewall endpoints to protect a large number of AWS VPCs.
And I think one extra call out here that sometimes gets missed is from that, not gateway cost being included in what you pay for your network firewall. That only applies if for that primary endpoint, like a primary firewall deployment. So in this scenario, if I have 3 endpoints for the same firewall stack, my NAT gateway costs are kind of zeroed out, but only mapped to one of those endpoints. So if I have more traffic through the firewall, so more traffic in general, I'm not getting those NAT gateway costs kind of zeroed out for every single endpoint I have.
That's right. That's absolutely right. And it's a pretty popular option for customers to be able to move from a a decentralized egress where maybe they have a lot of NAT gateways in their different VPCs and accounts to a centralized egress where they want to have network firewall and just a few NAT gateways. And with network firewall in that model, those NAT gateways are free. So a customer could move from having a lot of NAT gateway charges to using network firewall and a free NAT gateway. And so that's another kind of bonus and reason we've seen customers prefer the centralized egress architecture with network firewall.
Yeah. So if I have 100 VPCs with or 50 VPCs or 10 VPCs, let's say 10 VPCs with each one has its own NAT gateway. In each one, I'm going to deploy a firewall endpoint going to the same network firewall service. Ultimately, I would have one of those NAT gateways zeroed out, and the other 9 I would have to pay for.
That's exactly right.
Got it.
And just the other day, I was playing with generative AI, the different tools, and I was having it go figure that out for me. It looked pretty straightforward. It helped kind of make sense of that. Usually, what I do is I just ask Tom over Slack, and he gives me a good answer. But yeah, so one of the things we're focused on is a little side tangent. We mentioned the best practices guide a lot. We're trying to make sure that those best practices are super easy for customers to find and that they'll even be discovered by ChatGPT, Claude, so that when you ask those tools a question about network firewall, we want you to get a really rock solid answer. Cool. Okay. The other kind of infrastructure related feature in network firewall that we've released is around this architecture where customers would use network firewall with transit gateway. Transit gateway, as you know, is our routing in between VPCs, makes it centralized and much easier for customers to manage connectivity between different VPCs. And it also allows you to insert network firewall inspection between those VPCs. What this specific feature does is within a couple clicks in the console, you can tell network firewall and TGW to build the inspection VPC, and it will do that without you having to make decisions on the exact configuration of that VPC. So it'll build the VPC, it will it will create the firewall subnets that network firewall endpoints need to be inserted into, and it will stitch all that together without you having to do it. And so it's really just a streamlined, automated way to have this deployment architecture with network firewall and an inspection VPC. But in this model, you don't have to actually know how to configure and go through the steps of configuring that inspection VPC. This is most applicable to the what we call the east-west use case. So if I'm wanting to insert segmentation and IDS rules, IPS rules in between VPC A and VPC B, this is a great option because it allows me to very quickly insert that inspection VPC, go to TD, can't talk, go to TGW, change the route tables, and it'll automatically start inspecting that traffic in both directions.
Yeah,
Um,
I've seen a
mhm.
lot of customers like it's a one-off thing normally to get that firewall VPC configured, but it's so many routes in there and so many, especially if you have multiple AZs, it just becomes a bit of a pain for customers to. We troubleshooted so many cases where it turns out, oh, a typo in a route or a little bit of asymmetric routing there, and then I don't know where these costs are coming from, and why am I seeing asymmetric flows on the firewalls? So it's nice that we're removing kind of that overhead from customers having to worry about it.
Absolutely. Yes. I've built this manually, every attachment and TGW route table. And yeah, there's a lot under the hood that you have to make sure you touch and you get right. And so for us to be able to just simplify that for customers and automate it is a big win. You might be asking, well, what are the popular use cases for actually doing this? Why would you need this security deep packet inspection in between your VPCs? One of the big ones we see customers mention is maybe I don't want prod to talk to dev, or I don't want dev to be able to talk to prod. That sounds easy on the surface. You could do that with route tables, but what we actually see in the real world is there's always some exception to the rule. Like, oh, I have to actually have this specific thing in dev available to prod for testing or whatever. And so this sort of architecture allows you to make those sorts of decisions and exceptions in a very safe way, where you're saying, hey, between this specific source and this specific destination in another VPC, we're going to go ahead and allow it. And we're going to do deep packet inspection on top of it. We're going to have our IDS IPS rules ensuring that that traffic is safe, since we are kind of crossing those important boundaries between prod and dev, or dev and prod.
Cool. We get a question here from Tech First around creating sub interfaces on the network firewall. And I think it's an interesting question to maybe talk a little bit about how kind of network firewall is implemented, because there's some differences between how partner solutions implement these type of ways of connecting things. So that separation between east, west, and north, south, I guess I know with other vendors, like listed here, we have these ways of doing sub interfaces and different zones based on some interfaces. In this scenario, the network firewall is more transparent. You would probably separate north, south, and east, west by just deploying different firewalls or different firewall endpoints to deal with that use case. Is that right?
That's right. That's the most popular option. However, you can do a lot of consolidation. You could have a single firewall that serves multiple use cases. It starts to get a little bit tricky with making sure that your firewall policy accommodates both use cases. So it can, in some cases, make the firewall policy a little bit more complex. So I would say mostly customers prefer splitting those out, where they have like a egress only firewall policy. It's totally separate from their east-west firewall and firewall policy. And that makes those different use cases very easy to address and write rules for in the firewall without, concerned about, hey, when I make a change to the egress firewall, it's also impacting, potentially changing the east-west environment. But you can consolidate. And the multi-endpoint feature is interesting. I think about being able to consolidate for ingress inspection and egress inspection on a public subnet, for example. I could use my primary endpoint for the ingress, my secondary endpoint for the egress, and I could have both of those use cases on a single firewall and support that fully now. So that's kind of interesting. However, I would say most customers still prefer to keep those separate and have different firewall policies for each.
Yeah, because I think the good call out that even though you can do it with a policy, that those it's going to be the same policy governing all traffic going through the firewall. So if you decided to use that firewall for multiple use cases, then your policy has to be accounting for all of those use cases, which
Yeah.
means it's going to be longer, more complicated, potentially harder to troubleshoot. So I've also seen customers do that separation where they uh, like especially for ingress, because usually ingress is crown jewels. That's usually kept separate from anything else because you don't want to mess up your internet-facing application if you're, because you're updating your egress rules.
Yeah,
So that
absolutely.
separation makes sense, but it comes with a cost. So it's either going to be a cost of paying for an extra firewall, or it's going to be an operational cost of having a more complex policy, I guess.
Absolutely. Tom, do we want to touch on the reason to not use this native attachment feature?
Yes, I guess we can. We have, how much time do we have? We have 3 minutes, probably 3, 4
Okay.
minutes. Uh,
I'll
we
just
we
be
can.
fast with it. I'll be
Yeah,
really fast with it.
go for it.
So it's very popular, I mentioned, to have customers centralize egress with TGW and Network Firewall and a NAT gateway. In this new native attachment feature, you would be responsible for the NAT gateway VPC, which means you would be routing the traffic over to the inspection VPC, back over TGW, and then over to the NAT gateway and out. That would mean that you're incurring additional TGW charges. So for the centralized egress, you're probably not going to use the native attachment. You're probably going to build your own and have a collapsed inspection VPC and NAT gateway VPC all in the same VPC, so you don't have to reroute that traffic over TGW. Save you a little bit of money.
Got it. So this is from a cost, and if you build it yourself, it is the same as if you would put an inspection VPC separate to where you have your NAT gateways. So it means you have to go through the transit gateway twice, and each time you're passing through a transit gateway, there's an extra charge. So I'm assuming
Exactly.
we're getting requests from customers, hey, could we also include a NAT gateway in that managed VPC? So it's all together and I don't have to worry about anything anymore.
Yeah. And I think there's a lot of opportunity for us to do other things like this around native attachment and making it easier. For example, maybe a customer just wants to go to this is a wild one, and I'm not making any sort of roadmap commitments. Maybe a customer wants to go to an NLB and say, hey, I want to put network firewall in front of this, and I don't really want to know anything about how the routing works on the back end. That's kind of how AWS WAF works today. So those sorts of things, I think, we're very open to improving the automation behind the scenes for making the different inspection architectures work for customers.
Cool, very cool. And if folks on here, or if you're watching on demand, if you have feedback, pass it on through your account teams, or reach out to us on LinkedIn, or however you can. Catch us at an event, stalk us at home. Maybe not that last one. Uh, cool. Okay, I think we've hit time. We're gonna have to wrap up. Jesse, Sophia, thank you so much for joining. Thanks everybody else for attending. This was the last episode in the security season. I think we're going to move into observability. So you can check out future episodes on the routing loop page. Right now it's not updated, but we should update it in the next few days. Yeah. Thanks for joining, and
Thanks for having
Thank
us.
y'all.
It was
yeah.
great. Thank you.